Hello everyone, this is Shahrukh. Today again here with a new video of class 10th physics of chapter magnetic effect of electric current. Today I will tell you about the electric motor, that how it works, what is the construction of electric motor, and what is its principle. So before starting our topic, I would like to remind you that you all kindly subscribe our school channel and click bell icon on mobile for further notification. So students, now what is electric motor? What is electric motor? Electric motor An electric motor is a device which converts electrical energy into mechanical energy. Okay, so it is a type of device which is used to convert the one form of energy into the other form of energy, that is electrical energy into mechanical energy. This motor is based upon the magnetic effect of current. And students, I told you in last video that what is the magnetic effect of electric current. Okay, so now what is the principle, on what principle the electric motor works? Okay, so electric motor works on the principle that whenever a current carrying conductor is kept in an external magnetic field, it experiences a force given by Fleming's left hand rule. Means when the current carrying conductor we will kept it an external magnetic field, it will feel a force, and this force can be calculated by Fleming's left hand rule. Okay, so how it experiences a force? Generally I would like to tell you about that how electric motor works. As you all know, whenever we feel hot in summer, what we do, we simply switch on the fan. What we never think that how the fan is working. Okay, so when a conductor is placed in a magnetic field and the current is switched on, then it experiences a force in certain direction. Okay, now what is the construction, of electric motor? The construction of electric motors, I am going to tell you the main parts of the construction through which the electric motor can be constructed. That is, it has the following main parts, that is armature, commutator or split ring, magnet, brushes and battery. Now, what is armature? It is a rectangular coil which we can see in the diagram, that is ABCD. Okay, this is wound on a soft iron core, and this coil is known as armature. This coil is placed between the poles of a magnet, and the ends of the coil are joined to semicircular metallic rings, that is C1 and C2, which are known as split rings. Okay, C1 C2 we can see in the diagram. The commutator, so the two split rings are known as commutator, which changes the direction of current flowing through the coil. These split rings are fixed to the shaft and rotate along with it when coil rotates. Okay, so this is the construction of electric motor. Okay, now how this arrangement we can make? When we make such types of arrangement, okay, then we get a rotatory motion due to the force experienced by the current carrying conductor which is kept inside the magnet. Okay, now we have taken magnet, okay, whose north pole is there and south pole is there. Okay, the magnet always gives uniform magnetic field from north pole to south pole. Okay, this magnet gives uniform magnetic field. Now we have placed a rectangular conductor inside it, and if we observe, then the switch and we switch on the switch of battery is on, then the conductor will experience the force. Means when current will flow, then the conductor will experience the force. That can be find by using Fleming's left hand rule. Okay, that can be find by using Fleming's left hand rule. When the battery, when the current is not supplied from the battery, it will not act. Okay, this is the working also. When an electric current is supplied to the coil, then it gets deflected due to magnetic field. When it reaches halfway, then the split ring acts as a commutator and reverses the direction of current, due to which the direction of forces acting on the coil is also reversed. This change in the direction of force pushes the coil and moves another half turn. Okay, so as I have told you that the force experienced by a current carrying conductor kept in a magnetic field can be found by Fleming's left hand rule. Okay, so now what is Fleming's left hand rule? We stretch, if we stretch our left hand in such a way that in such a way that the thumb, the forefinger and the second finger, they are mutually perpendicular to each other, then the thumb will give the direction of force and forefinger will give the direction of field, magnetic field, and second finger will give the direction of current, direction of current. Okay, simply there is a simply I would like to tell you how you are able to learn or remember this Fleming's left hand rule. This Fleming's left hand rule. Do you know how you can learn it? Okay, I am going to tell you that whenever we are stretching our left hand, only three fingers, that is two fingers, sorry, and one thumb, we are stretching. Thumb is pointing about the force, and first finger, that is forefinger, pointing towards the magnetic field, and second finger gives the direction of current. Okay, so first force is denoted by F, yes, and magnetic field denoted by M, yes, and current is denoted by C. Simply we can say that F for father and M for mother and C for child. Okay, that is thumb is the father, thumb is the father, father means force. Okay, and first finger is mother and second finger is child. Mother means magnetic field and child means current. As you all know that first father comes, then mother, then child. Thus we can say that this is the Fleming's left hand rule, through which we can calculate the force. Okay, students, I hope you all got about it, understood. Now how it works, means how the electric motor rotates. So in the figure we can see there is a rectangular coil AB and CD, okay, which we can see that rotation is produced over there. How the rotation is produced? When current is flowing in an arm in upward direction, that is in AB arm, and it is in AB arm in upward direction and in CD arm in outward direction. On AB arm, the force is in upward, and in CD arm, the force is in downward direction. So, this force will give a couple, and this couple of force will start rotating the motor. This couple will start the rotating the motor. After the half rotation, means when the half rotation is completed, after that these two forces, that is upward force and downward force, will try to take the motor back in its original condition. Okay, so thus we can say that the half rotation is completed. When this half rotation is completed, then the motor is moving in one direction, and after half rotation the motor is rotating in opposite direction. Thus we can say that motor keeps on rotating in this way. Okay, I hope students you all got about this. When the force will be in reverse direction, then the direction of current in the armature will also be the reverse. Now the strength of the motor depends on the strength of the magnetic field and number of turns in the coil and magnitude of current. Okay, so there is a point which I am going to tell you, students. You all kindly remember these points. That first, in a commercial motor, armature coil has large number of turns wound on soft iron core. The armature of commercial motor rotates in the magnetic field produced by the electromagnet. Okay, so this is the point which you have to remember. Now what are the uses of motors? Motors are used in various tasks, like electric fans. It is used for pumping water. Okay students, I hope you all understood about the construction and working of electric motors. Now I am going to discuss about the question based on this. My first question is, when an electric motor starts to rotate, we can say in clockwise direction, there is a kickback and the body of the motor tends to rotate in an anti-clockwise direction. Here what famous law is being expressed? Okay students, I hope you can tell this answer. My second question is, name the device which converts electrical energy into mechanical energy. Okay, my last question is that if we are having a particular motor, then the speed of rotation can be increased by following a greater current to pass through the coil. Means for a particular motor, the speed of rotation can be increased by allowing a greater current to pass through the coil. However, there can be problems if the current is too large. Okay, so explain this how it is possible. Now I am going to tell you this answer. If the current is too large, then it will produce heat in the coil which may burn the motor. Okay, so it is not possible. Thank you, have a nice day.